Here we have three linear equations in three unknowns x, y and z. To find the triple of numbers x, y and z that satisfies all three equations simultaneously, we start by eliminating one of the variables. Now the easiest variable to eliminate between these three equations is the x variable. We can do that by taking any equation and subtracting some other equation from it. So let's write down the top two equations, and if we simply subtract them, we can get rid of the x terms. So we can take this equation and subtract this equation from it. We get 0. 8 minus minus 3 is 11. Minus 3 minus 2 is minus 5. Minus 1 minus 2 is minus 3. Now we eliminate x from a different pair of equations. So let's take equations 2 and 3. So subtracting, we get 0x or 0. Minus 3 minus 1 is minus 4y. 2 minus 1 is 1z. 2 minus 5 is minus 3. So now we have two equations in y and z. And we solve between these two equations to find y and z. The easiest thing to do is to multiply this equation by 5 and add it onto this equation. So multiplying this by 5 gives us minus 20y plus 5z equals minus 15. So just multiplied this equation by 5 and simply add the equations. 11 minus 20 is minus 9y, get 0z here. Minus 3 minus 15 is minus 18, and that's very convenient. Y equals plus 2. Knowing y, we can find z. So if we plug 2 into this equation, we get minus 4 times 2 plus z equals minus 3. So z equals minus 3 plus 8, that's 5. So now we found two values. We found y and z. To find the remaining value x, we plug those two values into any of the three equations. So it looks like the last equation is the easiest one to work with. So we have 2x plus y plus z equals 2x plus y, which is 2, plus z, which is 5, equals 5 on the right hand side. So we get 2x equals minus 2, so x equals minus 1. So now we found a triple of numbers that should simultaneously satisfy the three equations. You can check that by going to some online program like Wolfram Alpha and getting it to solve the three equations, plug them in, or we can plug these numbers back in to the three equations, and they should satisfy all three equations.